All right, guys, welcome back to Math Analysis for Thursday. So we're going to be working on the back side of the worksheet from yesterday. The back side of page 2 or page 4, depending on how you're counting. 15 through 23 is the ones we're not working on all of those, but that's the side of the page we're on. So this is going to take what we worked on yesterday and kind of move it to the next level. We're not just looking at atoms of elements anymore, we're looking at about compounds and molecules. So question number 15 said, how many grams are in 4.5 moles of sodium fluoride, otherwise known as NaF? Well, yesterday we said that whenever we are looking at taking the number of moles, all we have to do is multiply that by the mass or the atomic mass of the element we have to get the total number of grams. There's a problem with this one though. Is NaF on the periodic table? Not exactly. But here's what we do. Even though this is a compound, it's not on the periodic table, but its parts are. Na, sodium, and F, fluorine, are both on the periodic table independently. And just like it kind of works logically, if we have two parts to this compound, then the compound's atomic mass, or molar mass, would be equal to the two parts' masses added together. So we could find sodium's mass, we can find fluorine's mass, and just add them to find the molar mass of the compound. So if I look on the periodic table, the atomic mass of salt is 22.99, and the atomic mass of fluorine is 19.0. So together, these have a molar mass of 41.99. I'm just going to be a little generous here and round that. Say 42. So the molar mass of sodium fluoride is 42 grams. Again, we're able to find that just by adding the individual atomic masses of each element that makes it. If one of these had multiple parts, for example, there was 3 sodiums and 2 fluorines, then what we would do is we would add its mass for each of the atoms that it has in the molecule, right? But in this situation, there's only one of each, so we're good. So again, just like the calculations yesterday, we take the number of moles we have, 4.5, times the amount of grams per mole, which we just calculated to be 42. So 42 times 4.5, we get 189. We find out that in 4.5 moles of sodium fluoride, there's 189 grams. We're going to do one other problem here. Let's see. Here's my paper. We'll try out we'll do number 20. Number 20 looks good. No. 21 looks more fun. 21 looks so fun. Love 21. Okay. So 21 says, how many grams are in 2.3 times 10 to the negative 4th moles of calcium phosphate, which is Ca3, PO3, 2. Boy, does this problem look fun, right? So, what we're going to have to do is two things. First off, we're going to have to think about what the heck is this number, right? And then two, we're going to have to figure out the atomic mass of that element. So, or the molar mass, I should say. First off, whenever we have scientific notation in the negatives, what that means is simply that the decimal place, instead of moving to the right and the number getting bigger, is moving to the left and the number is getting smaller. So if you want a visible representation of what this number is, we would move it 4 times. 1, 2, 3, 4. So we get 0.00023 moles of this molecule. Very, very little amount, right? Well, we say a very little amount, but a mole is still 10 to the 6 times 10 to the 23rd. It's still a ton. So here's what we want to do. We know what this number looks like now. You can represent it in scientific notation, or you can represent it like this. That's kind of up to you, whatever you're comfortable with. But we want to find this. So like I said a minute ago, whenever we have a atom in a molecule or an element in a molecule that has multiple parts to it, such as we have 3 calciums, then we're going to find its mass, its atomic mass for calcium, and add it in 3 times. So here's what we're going to do. We have calcium, 40.08. Because of how many numbers we have here, I'm just going to round these where I can. So 40.08, calcium is going to be about 40.1, right? But we have 3 calciums, 40.1, 3 times. Now we want to look at our others. Phosphorus and oxygen, right? How many phosphorus do we have? Well, it looks like we have 1 because there's no subscript. But we talked last week about whenever we have these parentheses and a subscript outside of them, that this subscript is actually applying to everything in there. So let's write this how it actually is. For this, these go away, the 2 is going to multiply both of these. Currently there's 1 phosphorus, multiplied by 2 makes 2. Currently there's 3 oxygen, multiplied by 2 makes it 6. It's a lot. But we got to remember what those parentheses and subscripts outside of them do. So phosphorus has a mass of 30.97. I'm going to round that to 31. There's 2 phosphorus, so I'm going to write that twice. And then oxygen, we have 6 of those. That's 16 exactly as its mass. So 16, 16, 16, 16, 16, and again 16. Now for us to figure this out, its total mass, we need to add all of those numbers together. So that's going to be 40.1, 31, or sorry, 3 40.1s, 2 31s, and 6 16s. And in total, what I get is 278.3 grams. Hopefully my math isn't off there and I didn't miss something, but 278.3 grams is what I get as the mass of a single mole of calcium phosphate. I think it's calcium phosphate is what it's called. So if we know the moles, we know how many grams are in each mole, then we can multiply these numbers. I'm too lazy to write them again. So we're going to get this 278.3, multiply that by 0.00023, and we get that in total, we have 0.64 grams of this molecule, this compound. All right, what I want you guys to try out is, we did 15 and 21. I want you guys to try out all the ones in between there. 16, 17, 18, 19, and 20. All right? So, at this point, it's Thursday, May 7th. May 8th is the last day Originally last day for our seniors. I know that all of us are going to May 15th. But what I want us to do is I'm planning on, sadly, ending our school year here. Tomorrow is going to be the last day of lessons in most of my classes. I think I'm probably going to be doing some lessons in statistics and algebra 2 tomorrow. However, you guys have had quite a few problems to try out over these past few days. So I want to give you guys tomorrow, instead of putting some new stuff out there, giving you guys some time to work on these and do any of them that you may still need to catch up on, or email me if you have any questions on them. Now, whenever you do finish these, if you're able to, then you can email them to me, or you can drop them off at our next school drop-off. I presume we're having one next week, but I don't actually know. But you can email me pictures of these completed problems if you were able to do them, and I'll get those added into the gradebook. You may be thinking, I turned in my previous stuff, but my gradebook hasn't been updated yet. I'm a little behind on grading. Sorry, my bad. I'm going to be using this next week to catch up on grading, some of the school, kind of paperwork that I got to do to kind of cover with the state what all it was that I was doing during this time, what you all were learning, that kind of stuff, all that documentation. So I hope you guys have had a good year. I've had a great year. I know we've had ups and downs and difficulties with vectors or with projectile motion, but hopefully you guys learned a little bit. I had a lot of fun teaching it. Hopefully you guys didn't hate learning it, but it has been a great, wonderful year, and I hope you guys continue to do well in the next year. So with that, again, email me if you have any questions or you need anything at all, but otherwise, I guess we're signing off for this class.